Hi guys, it's astronaut Miss Sarah here, and I'm out in space, but good thing I'm wearing my handy dandy astronaut helmet. And so this week, I'm going to talk a lot about the things you can find in space, people that we sent up in space, and all the really cool stuff out there in the world outside the Earth. So, right now, I'm hanging out next to a nebula, and a nebula is just a bunch of space gas. And why is that so cool? Well, for one thing, it looks really cool. And another thing, this is either what it looks like when a star dies or when a star is about to be formed. Something when it's out in space, all of the gas and dirt and other elements that are out there will get kind of sucked in by gravity to create new planets and new stars and lots of other cool stuff that can happen out in space. So, come with me as we float through all the other cool stuff we're going to learn about this week.
All right, guys, now that you've seen me hanging out with this nebula, I'm going to talk about what is space, what's out in space, and kind of where everything is. And we're going to start out with, what is space? Where does space start? Well, for you down on Earth, you're on Earth. And Earth has a lot of layers between it and space. First up is the troposphere. That's where airplanes are, lots of really high things. Then you have the stratosphere, which is even higher. You can kind of go up there in a hot air balloon. A mesosphere, and that's where things like comets and meteors get all burned up so they don't reach to us. The thermosphere, which if you've ever heard of the Northern Lights, that's where all of those crazy colored gases are. And then the exosphere, which is basically where space starts to a lot of people, and where things like the telescopes and stuff like that are. So, and for a lot of people, space starts approximately 73 miles up from the Earth. So I don't think you can go that far, but it's pretty far distance. And all of these layers that we have, they protect us from the UV rays from the sun, lots of space dust that's out there, and things like that might hurt us. And all of these layers also help spread out all that heat, keep us nice and warm at times, cold, and really help our climate. So now that we've talked about where space starts, let's see what's in space. Well, Earth is part of a solar system. And it's called a solar system because it revolves around a star called the sun. And that's why you get like solar power, things like that. It means it comes from the sun. And the sun is where all of the other planets rotate around or orbit around throughout time. And when you look at it, it's mainly made of hydrogen and helium. Those gases like hydrogen, in the air, and then helium, that gas that makes balloons float, that's what makes up the sun. And the sun is full of little bitty reactions, making it super hot and super dense. It is over 99% of the mass of the solar system. So it basically takes up a lot of space. And it's really, really hot. And the reason that the sun looks the same size as the moon is because though it's 400 times bigger, it's also 400 times farther away. So that's why they look the same size to you. All right, so now I'm going to talk about all the planets that hang out with the Earth in this solar system. So first up, we've got Mercury. It is the smallest planet. It's closest to the sun, and its rotation days, or its orbit, is only about 87 days. So Earth's takes about 365. That's a full year. Mercury's year only lasts 87 days. That's super duper quick. It also fluctuates in terms of temperature. You know how for Earth, we don't really get super duper cold or super duper hot. In Louisiana, it might feel like we're super hot, but we're not as hot as it can go. But with Mercury, it can go up to 800 degrees Fahrenheit and then minus 275 degrees. That's over 1,000 degree fluctuation. So we don't even fluctuate more than maybe about 30 degrees. They do 1,000 degrees, which is a lot. But nobody really lives on Mercury. And it's got a big iron core. The Earth has layers. This takes up even more than the Earth's core. And NASA has actually mapped all of Mercury. Miss Sarah cannot say that word right. And so we know everything that's been on it. And we also know that it was once hit by a giant asteroid. So it was hit, and it's 960 miles across. Is the crater that it created. And it's bigger than the whole state of Texas, which is huge. All right, guys, now that we're in Mercury, we're going to float on farther away from the Earth and check out Venus. Venus is the second planet away from the sun. It's actually hotter than Mercury, even though it's closer. It's because there's a lot of carbon dioxide in Venus's atmosphere. And that's something that we deal with even on Earth. When people talk about trying to get the carbon dioxide out of our atmosphere, it's because it can heat things up. And that can really mess with things like in our cold weather places, like our glaciers and stuff like that. So also something special about Venus, it spins clockwise on its axis. A lot of the other ones spin counterclockwise, which is pretty crazy. And if you look into the sky, it's the second brightest natural object at night after the sun. And I don't know if you noticed something yet, but we've got Mercury and Venus, and they're named after Roman gods and goddesses. Much like you've heard of the Greek ones, the Romans had the same ones as well, and they were kind of the people a lot of times to discover some of this stuff, so that's why they have all of these Roman names. So now that we've checked out Venus, we're gonna float on past Earth, which is the third planet, and talk a little bit about Mars. Did you know that we just sent another Mars rover over to Mars to check it out? It just had its blast off a couple days ago, so you can follow it online. And Mars, like Venus and Mercury, is named after a Roman god. It is also the red planet because it has a ton of iron oxide on it. So if you look at it as something that's a piece of metal and it's been outside for a while, or it's really old, it's got that brown color on it, that's because oxygen has mixed with the iron and made iron oxide. And that's what makes Mars so red as well. And you can actually see that it's red if you look up into the sky. It's kind of small, but you can find it. And then Mars is colder than the Earth, which tends to happen the farther you get away from the sun. The sun's pretty hot, so the farther you get away from it, the colder it's going to be. So in the middle of Mars, it can be about 20 degrees Celsius, and then on the poles, it can be low as 140 degrees. So this is also something that we look at when we're trying to see about space exploration. How cold is it? Can humans live there? And one important thing that Mars has is it has the presence of water. They found ice on Mars, which means that we could possibly live there in the really, really far away future. And the farther away you get from the sun, the less gravity there is. So if we decide to move to Mars, there's less gravity, which means we can jump higher, will weigh less, and lots of other crazy stuff that gravity keeps us to Earth. Mars's gravity wouldn't do the same. So in a year on Mars takes 687 Earth days. That's a really long year. It's a little bit less than double, but it's still a really, really long time. All right, so now that we've learned a little bit about Mars, let's float our way over and check out the asteroid belt. So between Mars and Jupiter, there's a ring of asteroids that hang out in the orbit of the sun that we call the asteroid belt. And asteroids are just kind of basically large space rocks, but they're not as big as a planet. And so they just kind of hang out in this asteroid belt. If you've ever seen Star Wars, they get caught in an asteroid field, and it's like that. They're hanging out pretty close together, and it could be kind of dangerous to go through unless you know what you're doing. They've got some stuff that have names, and really when you think of it, it's super crowded in your head, but in space, everything's pretty spaced out. We're not that close to the moon or that close to the sun. So things that might be considered close in space aren't that close at all. All right, so now that we're going to float on carefully through this asteroid belt, we're going to check out Jupiter. And Jupiter is the largest planet in this solar system, and it's huge. So for every one Jupiter, so the one big Jupiter that's out there, that's 318 times as big as the Earth. And it's 2.5 times bigger than all of the other planets combined. So it is pretty dang big. And a lot of it is made out of gas. So it's not as thick, like, you know, with Earth, we've got ground. There, a lot of gas, so it's not as dense as, say, the sun. And so it's also got some huge, thick clouds in it, how it's made up of a lot of gas. And it's got this really big storm that they actually consider an eye, because you can see it from space. It's a huge storm that keeps swirling and swirling and swirling, and it's really cool. It's been around for a really long time. People spotted it on Jupiter as far back as the 1600s, which means that's a storm that's been going on for a while. What if a thunderstorm here on Earth had been lasting since the 1600s? It would be pretty crazy. And then Jupiter also has rings on it. They're not as big as Saturn's rings, which is Jupiter's neighbor, and we'll talk about in a second, but it's still got pretty good rings and stuff orbit around it. It also has, like we have a moon, it has moons that rotate around it. A lot of the planets do. And then its magnetic field is 14 times stronger than Earth. So, like Mars, you could jump really high. This one would keep you super duper close and could squish you because of all of the different elements that are on Jupiter. And then, so it's been visited 7 times by spacecraft. Lots of kind of telescopes and other spacecrafts that are just kind of sent into space and just kind of take pictures of it. You can actually see it in the sky with your own eyes, but you might need a telescope to really understand what you're seeing. So now that we've checked out the biggest planet in the solar system, we're going to check out its neighbor, Saturn. So Saturn is the most distant planet that you can actually see looking out to the sky right now. And it also has really, really distinctive rings that you think of. So Jupiter has them, and Saturn has even bigger ones. It's also got a lot of moons. So the rings have been, you could see them, and people could see them since the 1600s as well. So a lot of them, they're made up of dust and rocks and grains and ice and lots of things, but they're rotating around Saturn like the planets rotate around the sun. And they keep it with that gravitational force. And it's Saturn is composed of hydrogen and helium, much like the sun, but it's got a lot of other stuff in it as well to make it not be like the sun. Saturn has the most moons out of any planet. It has 82 moons, which is actually 3 more than Jupiter. And it's got one of the most famous moons called Titan. And it is really big, really large. It's made out of ice and rock and a lot of nitrogen. So that's a really cool thing about Saturn, outside of its really cool rings. All right, now that we're floating past Saturn, we're going to check out Uranus. Uranus is known as the sideways planet because it rotates on its side, as opposed to, you know, how Earth has a north and south pole, and we rotate around those every day. That's what makes a day. Uranus rotates on its side. So that would be if we were completely flipped over, and if things like Central America and Asia were actually the North and South Pole. That would be pretty crazy. Uranus is the first planet that was ever found using a telescope. Up until Saturn, you can see it just by looking out into the sky. But it was the first one that we discovered while looking through a telescope with all of those special lenses. And Uranus is an ice giant planet. It's made of mostly ice, and because it's so far away from the sun, and it's nearly 4 times bigger than the Earth. It's pretty cool. It also has a couple of rings, just like Jupiter and Saturn. And then, unlike Mars, we know it definitely can't support life. It's super important for any planet that we want to know, that humans might want to go to, have water, because we've talked a lot about that, and there's definitely no water on Uranus. So next up is Neptune. Flipping on past Uranus over to Neptune, and though named after the Roman god of the sea, we can't live on there either. It's the most distant planet from the sun in our solar system. You might think it's another planet, but I'm going to talk about that once we've talked about Neptune. So Neptune has 6 small rings. You can't really see like Saturn's, but they're still there. A year on Neptune lasts 65 Earth years. That's a really long year. That means nobody would ever really go past the age of 1. It spins super duper quickly. How it takes us 24 hours to have a day, it only takes 16 hours for Neptune to have a day. That's because it's mainly made of gas. So it's not very solid and doesn't have a lot of stuff going on. It's got a heavy atmosphere, but it's not full of things like iron and metals like the Earth has in its core. It has 14 moons, and only 1 spacecraft has ever flown through past Neptune. So I said that Neptune was the last farthest planet in our galaxy. But you might be thinking about Pluto. So Pluto was named after the Roman god of the underworld, and it was thought to be the last planet. It was classified as a planet discovered in 1930, and it was a planet for 75 years. But in 2006, we found another dwarf planet hanging out in our solar system, so it got declassified as one of the main planets in the solar system. What's kind of sad about it, Pluto didn't even get 1 full rotation around the sun without being declassified. So there's been a lot of discussion about what Pluto is and isn't, but it's not considered a planet anymore to most scientists. And what's a fun thing about Pluto, a fun fact to know, is its orbit takes it closer to the sun than Neptune, but also at times farther than Neptune. So at times it can be closer or farther away. And it also has moons like any of the other planets, but it's just super, super small. It is about 1/6 of the moon's mass and 1/3 of the volume. So it's smaller than even the Earth's moon. That tells you how small it is. All right, guys, now that we've learned about all of the planets and former planets that are part of our solar system, we're going to keep on floating out into the vastness of space. So what we're going to learn about is we're in a solar system, which is part of a galaxy. And there are lots and lots of galaxies throughout the universe. And we're part of the Milky Way, which has the same name as that candy bar. So we're part of the Milky Way, which centers around a big black hole. And a black hole is where gravitational pull pulls everything in so close. It's light, it's matter, it's everything. And we can't really take pictures of it or any black hole because it has such an intense gravitational pull. Once stuff starts to get pulled in, whoop, it kind of disappears. So we just know that things rotate around that black hole. So the Milky Way measures about 120,000 light years across it, from one end to the other. And it's got lots of arms and legs and spirals and things. So it's not like a big circle. And it's just kind of being pulled around, and we rotate around, and it's constantly moving. It has about 200 billion stars, much like the one that we rotate around. So we've got our special star, and there are about 200 billion of them in the Milky Way galaxy. And it's made up of other galaxies that have kind of broken apart throughout time. And so in those 200 billion stars that are also in the Milky Way, there might be planets just like ours that have the things that human life needs to survive on, or life that we know of it to survive on. And it's really cool that we can try to explore it and see what's out there. There are a couple of planets that telescopes and other things that have been sent out into space have seen and possibly might have life on them, which is really, really cool. And then it's also so we're in a solar system that's part of a galaxy. And then our galaxy is part of a supercluster, which is a group of galaxies. And this one's called the Virgo supercluster. And it's got about 100 galaxy and clusters in it, which is a lot of stars and a lot of space. And it's about 150 million light years from end to end, approximately, because everything is constantly moving. And there's a lot that we don't know about space that's out there. We've never taken a picture of it. We're located about 26,000 light years away from it. All right, and so that's as far out as we're gonna get. Now I'm gonna talk about some of the stuff in space that you might not understand, or that might just cool facts to know. And some of the stuff that I've talked about is light years. And a light year is how far light can go in one whole year. It is super duper fast. So it can mean a really, really long distance away. So we can't see and take a picture of the Milky Way, our galaxy, because humans as we know it haven't been around for that long. So even if the first humans on the planet sent out a telescope to go take pictures, it still wouldn't be that far away. And so that's why a lot of times when we just look at things, these are pictures that other things have taken, and we have to zoom in super duper close. So we can't always see the exact details. Like if you took a picture and tried to zoom in super duper close, it starts to get a little blurry. And that's what we're dealing with in the farther out regions of space. So some other things that we can talk about. So we're in the Milky Way galaxy, and one of the closest ones is the Andromeda galaxy. You can actually see the whole thing with your eyes. It's about 14 billion miles away, which is pretty far. And things like the stars where we get all that light, it's light years away. So we're seeing light that actually started out probably before even the dinosaurs roamed the earth. And stars don't twinkle because light is a pretty straight beam, if you will. And it doesn't twinkle until it gets into our atmosphere. With all of those different layers, it kind of refracts, like if you look into a glass of water, stuff looks a little funny. That's what makes stars twinkle. And if you ask an astronaut what space smells like once you get out of the atmosphere, some of them say it smells a little like something's burning. A lot of them say that it smells like sulfur and kind of sulfuric things, kind of like a rotten egg. That's the kind of smell that it has. But not a ton of people know, because there haven't been a ton of astronauts that have gone and checked it out. And so in terms of checking out space for humans, Russia was the first person to send someone to space, and the United States was the first person to land on the moon. And when they landed on the moon, they planted a flag it's the American flag. And in that time, if you look at it now, it's actually just pure white, because all of the radiation and light from the sun has completely blanked it out. Have you ever left a a book or a piece of paper or even your toys outside in the sun for a long period of time, they're not as bright as they used to be because the UV rays can break down all of the pigment and things like that in it, so it becomes almost white like the sun. So if you leave things outside, those UV rays can get it, and that's what happened to the flag that's on the moon. And as of right now, we're looking to try to go to Mars. It can take years to get there, so we have to really be prepared and know what we're going into. And that's why they sent out the Mars rovers. So how about we check back in with me out at my nebula?
All right, welcome back to the nebula, everybody. All right, I hope you learned a lot of cool stuff about space this week and all the cool things out there. And I'm gonna sign off and float my way back home to the West Bank. And until next time, just remember, like my favorite astronaut said, to infinity and beyond!